Hello, everybody. Thanks for attending this session today. It's going to be a very intense couple of hours, so be patient and stay with us. We are going to describe you the procedure to attend the entry test for bachelor degree in architectural design and building engineering at Politecnico di Milano. In the first half hour, we will discuss bureaucratical and technical procedures through CISIA and Polimi website. In the second part of this presentation, you will instead, we will discuss with you the content of the test in all the details. So I will leave the word to my colleague Alessandra for the start of the procedure that you will have to go through before attending the test. Enjoy the day.
Thank you, Cristina. Hello, everyone. Good afternoon. Let me introduce myself. I'm Alessandra from Student Secretary, and today I'm talking about the procedure to register in architecture test. Okay, before to explain better the procedure to complete the registration, let me start by giving you some specific information. The admission test for academic year 2020-2021 will be on September 2nd, and the admission test will be online. ARCAD test consists of 40 questions with 5 answer options. Just one is correct on this subject. General knowledge, logical and reasoning, history, drawing and visual representation, physics and maths. And the ARCAD test lasts 70 minutes. The admission test will be provided in Italian and English language. So during the registration procedure, you can decide if you want to register in the admission test in Italian or in English. This is the places available for next academic year. Regarding the Bachelor of Science in Architectural Design, in Milano campus, we have for Italian and equivalent students 745 places available, and for the non-EU students 55. In Milano Leonardo, we offer the course in English language, and for Italian and equivalent students, the places available are 50, and the same number for non-EU students. In Mantova campus, the same courses are teach only in Italian language, and the places available are 19. For non-EU students, 2. In Piacenza campus, from this year, we offer the same courses in Italian and in English language. For Italian and equivalent students, the places available for Italian courses are 50, and for non-EU students are 2. While the course in English in Piacenza are in English only for international students, and the places available are 50. While for the course in Lecco campus, and the course is a 5-year single cycle program in building engineering and architecture, the places available for Italian and equivalent students are 108, and for non-EU students are 2. The registration procedure. You must know that the registration procedure must be done in 2 different websites. The first is on Polimi website from July 22nd to August 27. And the other registration you have to do on CISIA website in the same period. The admission test will be on September 2nd, and the ranking, there are 3 different rankings. The first ranking from 8 to 10 of September, the second ranking from 50 to 70 of September, and this is the last ranking for international students, and the third ranking from 22nd to 24 of September. How you can register on Polimi website? You have to register in the online services in order to obtain the credential to access on your personal account. And when you open your personal page, you have to find the following link: Laurea equivalent to a Bachelor of Science and 5-year single cycle programs, entrance or discharge tests and enrollment. You have to enter in this link and complete the procedure in order to register in architecture tests. During the registration, you can select the study program where you want to enroll, and you can select up to 6 programs in order of preference. After completing the form, you can decide to enter again in the Polimi website to change your preference. And you have time until the last day of the registration in order to change it. And in this case, the last day is the 27th of August. How you can register on the CESIA website? You have to create an account on CESIA. You have to select ARCED test, and then you have to choose the Politecnico di Milano as a university where you want to register. Select the language you want to take the test, in Italian or in English, and the last step is the payment. The cost of the admission test is 30 euro, and you can choose 2 different payment methods, by MAV or by credit card. The admission test, so on the September 2nd, the date of the admission test, you have to remember that you have to go to the CESIA website in order to take the test. And then to take the ARCED test, you must make sure that you have some specific equipment listed below: a stable data network to access on internet, a desktop or laptop PC connected to the power supply and to internet, a smartphone or tablet connected to the power supply and to the internet with a video camera. The video camera on the mobile device is very important because we use it for the identification procedure and for the control by the virtual test room supervisors. Then you need a paper completely blank to take notes and a pen. And you need the possibility to use a room at home, quite silence, with no other people in the room. The score to pass the test. The maximum score a student can get is 60, according to the following criteria: plus 1,5 points for each correct answer, minus 0,4 points for each wrong answer, or 0 points for each not given answer. The position in the ranking. Let me explain better the name of the position that will be available when the ranking will be published. In fact, you can be considered or assigned or reserved or pending. Assigned means that the enrollment is possible in your first chosen. Candidates who don't enroll within the deadlines are regarded as renouncers and they lose their right to enroll. Reserved, you can enroll if you are considered reserved, and the registration is possible, but not in your first choice. You will be considered eligible for one of the other choices, one of the other courses indicated during the registration process. And in this case, you can or proceed with the enrollment in this course or express an interest to be considered in the following rankings. While for a pending position, means that the enrollment is not possible. You cannot enroll in any choices expressed during the registration procedure. If you still want to be considered in the following rankings, you must express your interest on Polimi website. About the English language requirements, all the students who enroll in a bachelor, they need to attest their knowledge of English. And in fact, therefore, together with the entrance test, you will be asked to take an English language test. This consists of 30 multiple choice questions and at last 50 minutes. The result of this English section is not considered in the final test score and for the formulation of the rankings, so don't worry. If you want to enroll in architectural design course in English language, you will also submit an English language certificate. The deadline for this being the end of the first academic year. These are the English language certificate accepted from Politecnico. We have 3 different TOEFL, TOEFL CBT, TOEFL IDT, TOEFL PBT, TOEIC, IELTS, Trinity College, and Cambridge. So, thank you. I hope to see you very soon, and good luck for the admission test. So, I leave the floor to Professor Cocchiarella regarding the presentation for the school.
Hello, thank you very much. Okay, shall I start? Welcome everybody. I am Professor Luigi Cocchiarella, Associate Professor of Architectural Drawing at the School of Architecture and Vice Coordinator of this bachelor course. Today we will talk about how to approach the test in terms of contents, and we make some short simulations. In the short time we have, we will try to give you an overview about how to face this important for you appointment. We can look at the slides now, if possible. These are the presentations scheduled today. First one is mine, half an hour each. First is about drawing and visual representation. You expect to have 6 questions on the questionnaire on this topic. Then we have Professor Maria Cristina Lorenz about, she will present the topic general knowledge and history, and then at the end Professor Maurizio Venello about logical reasoning, physics and maths. So let's go on the topic drawing and visual representation. It's me, Luigi Cocchiarella. First questions, why we'll have a test of visual representation and drawing in order to enter a School of Architecture? Because drawing and visual representations are the language that architects use to support spatial thinking, project development, and building processes. We know that architecture is something 3-dimensional. It defines the space, the urban space, the private space in which we move every day. What is about? Precisely space. And we will deal about the relationship between space and image. In other terms, how to translate and control the 3D space by using 2D images. How do we do this? By means of projection section processes. We will explain a little bit what is and Dealing with metric and graphic distortions. It is quite cryptic, this statement, but I hope that soon you can understand what it is. Now, I will give you a short demonstration. Looking at an image, you know that the form of the image depends on the point of view. You know this set of objects, but they could appear in many, many, many ways. So you have to become used to explore and to recognize spatial elements as like an astronaut in the cosmic space. According to the point of view, they show in a different way. Normally in computer graphics, you see several contemporary representations. We have a top view, you have a perspective here, and you have front view and side view. Sometimes things are made more complex thanks to the shadows. In addition to the complexity, to the natural complexity of the distortion that images produce at the change of the point of view, we have additional elements that can make the situation even more complex. For instance, shadows. You know that the shadows can change. They are a physical representation of the projection. You know that sometimes the shadows could cover other objects. Sometimes they cast on the ground, and depending on the slope, they are short or long. Some of the questions, they deal with the slides, and they ask you for recognizing slides and the relationship between shadows and objects. Some other important options are given by questions asking you to recognize sections. It means that we can cut objects, and then we can be asked to recognize the objects according to their sections. When you draw a plan view of a building, we normally show a planar section like this. All the parts change according to the movement of the plane. Sometimes the section is vertical. Like in this case. And you know that according to the motion of the section plane, several new profiles appear. Well, you have to become able to recognize objects by recognizing their sections. This is one of the most challenging things for the new students in architecture. I don't know how many students have already followed the technical schools. That's the reason why I will try to start from this exercise. In other cases, you are asked to discover how an object has been split. Maybe in some questions, the answer is, can the two objects match? In that case, you have to activate your mental simulator in order to imagine, to figure out which the motion, the process has been, in order to split the object and to move one part in another place. This is something that you have to do, let me repeat, as if you were in the cosmic space. You have to become very used to this kind of visual transformation affecting the same object. Sometimes a developed object is offered to you like this. And the question is, what is the real object when you imagine to fold the planes and to close up the box? In that case, the answer is very easy because it is a box. Sometimes you have the initial object and the question is, what happens when you develop it? And then you will find some images in the options, including the right one. So again, you have to become able to explore any possible visualization of the objects. I think that's all for now. This is the set of things I wanted to show you at the beginning, just to set the problem. We can go back to the presentation now, and we will deal with these distortions. So at the end, we can guess from this short demonstration that we have thousands of images for each 3D spatial sets. Then drawing leads you in a virtual world based on some prerequisites that you have to know. Let me go back to the history, at least on the legendary origin of drawing, which comes from an act of love. It seems that it is like this: a young woman outlining the profile of a young man. The outline is generated by the intersection point between the yellow light rays and the canvas. Originated a very known process in the technical field, which is a projection and section process. It has been inspired by the nature, but soon mathematicians and artists, they rationalized and formalized in mathematical terms. So they identified two, at least, typologies of shadows in relation to the light source: conic, which could be conic, like you see on the left side, or maybe cylindrical, as you can see on the right. And they generate the technical forms of representation. All the drawings, all the technical drawings you will face during the architectural curriculum, they are based on this or on this other principle. Shadows has also used for metrical calculation, very important milestones in the history of science, but also in art for creating special impressive figure, but most of all, in order to emphasize volumes in architecture. So it is a topic that architects have to know very well. And this is to show the real strong and close friendship we have between drawing and its natural origin, which is shadows. I invite you to look at these images to understand the great similarities. Both the shadows on the right of the object on the right is produced by the same process which is represented on the left side by means of artificial graphics. Let's enter now the topic of the projective forms of representation. We'll try to offer you example about perspective, axonometrics, and orthogonal projections. Let us summarize the principle. This is the projection section. Projection section means that given an object in the space, you work on a paper sheet, which is like this, the pie plane. And the form of the image projected on this plane from the real object depends on the position of the center of projection. This can be a real point or maybe a point at infinity, and the projection could be conic or parallel. In the case of conic, we have perspective, and in the case of cylindrical, we have axonometrics. In the same of cylindrical, duplicated for twice, so we have a couple of projections. In that case, we have orthogonal projections. Please focus on the fact that you are drawing on the yellow part. The image you see in the questionnaire, they are supposed to be produced and generated on the yellow part, on the yellow paper. Let's enter now the topic of metric and graphic, as well as visual foreshortenings, which is the core of the control of drawing to control the space. It is about distortion, let me say, with an intuitive word. Starting with perspective, it is a conic projection. It is generated by the very abstract procedure. You see the spatial phenomenon on the left, and on the right, what you see on the paper. And the humanization of this process, when you put a human being with a height set at a specific height and from a specific distance from the picture plane and so forth. The final result is normally images having this kind of pattern. Things become smaller, smaller with the distance, and the parallel line, they tend to converge to a vanishing point, which is an invisible point, ideally at infinity. Let's go now on axonometric and orthogonal projection. They are cylindric, or they are also called paraline projections. I compare the two, axonometrics on the left and the orthogonal projections on the right. On the left is presented the spatial situation. We have the two picture planes. They are supposed to be two paper sheets located in this way, and the real object is projected on the first and on the second one, according to directions of projections which are perpendicular to the planes. The final result, the graphical result, the 2D image resulting, is composed on these two images. The image is split in two. Each image is like a picture of the object, first from the top, like this, and second from the front, like this. For a kid, this is just a couple of circle and triangle, but for an architect, it is a kind of something representing a 3D hologram, the 3D hologram which is symbolized on the left. So every time you face a couple of orthogonal projections, please try to reconstruct the spatial situation originating it, as well as when you are in the presence of the real building or the real object, try to imagine, to figure out how you can transform it in a technical drawing, as well as the one on the right. Of course, further constructions can be carried out on the drawing. That's the reason why we can design. We can use it for preparing projects and new things. And of course, we can apply this principle to the architecture. You see a simple house with three projections. This is the spatial situation on the left represented in axonometrics and the three projections on the right. Sometimes we can also cut the object to see inside. We said at the beginning that architecture is about space, and a house is a house not only because of its relationship with the context, but also and especially because it is interior space where people live. We can section in any way, horizontal, vertical. We can have some kind of cross sections, and we can have multiple sections and combine them together. Concerning the composition, we are totally free. Don't get confused. The two images, they represent the same three projections. Mind the baseline is the most important. It is representative of the base of each projection. And another recommendation, by experience, I would like to recommend you not to confuse projecting object, which is you project the whole object on a picture plane here, here, here. We have three pictures of the same object. Don't confuse this with an unfolding or developing object, which is the last example I showed you by computer graphics. Another important point to take into account, sometimes questions with this, do not confuse dimension and scale. Dimensions is the proper size of the object. The scale is its size in relationship to the size of the human beings. This can be a real space if the human being is supposed to be as big as this, or maybe a small model if the human being is supposed to be in comparison as big as this one. Let's enter now to the composition of any drawing, any image, any picture, any digital appearance. It is made of geometry and graphics. Geometry and graphics are the basic bricks of any graphic representation. Here, an abstract simulation where you can see emphasis on geometry. On the top, you have the same geometry triangle with different graphics. And below, you have the same graphics, which is the physical material, the pigment, the red color, applied to different geometry. When you combine this, you have any kind of images, and this is valid for the past and for the present. Whatever is the tool you use to generate images, you have these two levels. One is the logical organization of signs, and the other is graphics, colors, no matter whether the palette is analog or digital. Some advices now. Consider that your eyes as architects are special radio telescopes. Use them as working tools. Michelangelo Buonarroti, you know who is, said, use your eyes as sextants, as the navigators on the sea, and feed your mental space a simulator. We saw at the beginning how much important is this. Just to summarize, these are the three basic situations under which an object can show you. You can have axonometrics, you can have orthogonal projection or perspective, normal perspective, upwards or downwards vanishing perspective. But these are the three macro cases. A parallelepiped can show only in these ways. Once you consider representation and you read the questions, please be careful about at least three things. Orientation first. Try to understand which side of the object you are looking at. And distances and foreshortenings, foreground and background. Be careful, sometimes the foreshortening appears like this when you are working in perspective with the vanishing points, things becoming smaller and smaller with the distance. In the axonometrics, the objects simply translate in the space without changing size. And dimension and scale. How to practice? First of all, observing things. From this moment on, try looking around you and to understand what is the form of any object and create your mental image for anyone from any point of view. And you have also a powerful tool nowadays, which can help you very much. Use your mobile phone to take pictures, targeted pictures, to study, to investigate the space. Let's enter now the test. We will start from recognizing projection. Some questions, the question you see here, they belong to the past questionnaires, the questionnaires that the students attended in the last years. And normally the questions are like this. You have a figure, you have a question at the top, in this 52, for instance, and you have 5 options for answering. And in this way, they show you what is the representational form. If you use a pencil, you can easily understand that it is an axonometrical view. Sometimes the same axonometric is presented as a section, axonometrical section, downside up. Don't get confused. You see that the lines are parallel, bundle of lines, they are parallel, and it is an axonometrics from upwards. Sometimes you have exploded objects, especially for the construction. Sometimes it's useful to separate the elements in order to indicate to the builders how to connect them and what are the pieces to be considered. Sometimes the question is about which form of representation is. You draw lines, you understand it is a perspective, they become closer and closer. It means that you can discharge any other, but not A, which is the right answer. Sometimes how many vanishing points can be found? We learned that vanishing points are the meeting points of the depth lines, and we will see we have 3. So the question, the correct answer is A. And so forth. In this case, we have a section, we have a plan view, we have front and section. Sometimes they appear combined in order to show at the same time interior and exteriors of the objects. And this is a perspective. There are some special cases as usual. Sometimes you can get confused. For instance, these 4 objects, they have the same projections. If you choose a light source oriented in this way and you imagine to project the object on a canvas which is horizontal, we see that the projection is actually the same. And the question is about it. What do they have similar? The top view. In fact, the view from the top is the same from the 3. If you have a second view from the front, you can distinguish them. And this is a test. Now you have 1.5 minutes to try to answer the questions. Try to match the 3D objects with the planar representation. We cannot see the answer, but try to enter this stressful process of working fast. "20 seconds more. You can take a snapshot of the screen, of course. Okay, this is the right. 1 is with 3, 2 matches D, 3 matches A, 4 matches E, and 5 matches B. Okay, let's go now on the other topic we faced at the beginning, shadows. The question is, which is the right direction of the light projecting the shadowing figure? And we have several answers. Here, we have the advantage of the light represented in the image. That is, So you have to do nothing else than figuring out these triangles and to calculate the angle. You see very clearly that the angle is minor than 45 degrees. So the right question is first. Which composition corresponds to the shaded plan view shown above? This is a kind, we don't enter the details, we don't have time, but this is the kind of question you can face. According to the elevation of the object, you can calculate the more an object is tall, the longer the shadow. In this case, this could help you to understand that this is the only chance you have, because in all the other cases, you have different form for shorter elements with different other components in front, and the right choice is A. Now, this is a new exercise for you. Select the right position of the observer. It could be 3, 1, 2. You have to understand in which direction among 3, 1, 2 we are looking. If north is in front of us and we are looking in front of this part, which is this. 1, 2, 3, 4, 5 pieces of facade. It is 1 second hidden, 2, 3, 4, 5 pieces. Consider we are in Italy, north is there, west on the right, and east on the left. East on the right, sorry. Okay, I talked a lot, 1 minute for solving this. Shadow is in the opposite direction of the light. When you have a shadow in front of you, the light is behind you. When you have shadows behind you, the light is in front of you. This is the answer. It is 3 and afternoon, because the light source is from west, from southwest. It means that we are in the afternoon. Sectioning is the other challenging topic. This is very difficult. Sometimes you have images of objects like sculptural objects. We have several section lines, and we have to match. You have to find the correct relationship between each section plane and the sections shown there. We don't enter the details of this because we have other exercises. In this case, it is a natural environment with a river here, a little creek, and we have a section, and you can understand A without trees. The circles here represent the trees, so you can understand the section B is related to this when you can interfere with 1 tree, and this interfere with 2 trees is this one, just to give you an example. Now, this is a new exercise for you. Consider the plan view, the 3 volumes, cylinder and some parallelepipeds there, and the section planes there. Try to match section A, B, C with the right profile, 1, 2, or 3. 1 minute. Well, this is the correct answer. 1 matches CC, 2 matches AA, and 3 matches BD. Let's focus on 3, the profile 3 is small on the left, big on the right, and tall in the middle, height in the middle. So we have this, starting from left to right, on the section plane, we see a thin part on the left, we see small and high part in the middle, and we see a very big part on the right. The width of this part is the biggest. Okay, another exercise could be, which section is related to the section of the church shown below on the right? A, B, C, D, E. In order to establish which one, look not only at the direction of the section plane, but also in which direction you are looking at. In the case of B, for instance, are you looking left or right? Okay, 1 minute from now. More or less. BB is the solution. In fact, if you start from the left to the right, you have a big part here, which is corresponding to this one. Then you have 1, 2, 3 big intervals, 1, 2, 3, and then you have a small one here and a curved part on the right. This is the way, following step to step. Some other questions could be very similar. Many of these questions are in the questionnaire we have to answer, because plan and section and the ability to combine or to recognize which section is related to each plan view is one of the most relevant abilities the students have to acquire in order to become able to attend a School of Architecture and to realize projects. Again, this is another similar exercise. Computing by images is another interesting task. Sometimes you are asked about the scale. You have here 2 drawings. One is half and the other is the double in terms of size. And here you have several scale factors. Of course, the answer in this case is A. And you know that if the denominator is double than the previous one, the drawing is half the size compared to the previous one. Same in the topographic map. If the big one is 1 to 50,000, what is the scale of this? Of course, it is related to this quadrant, and it is in a bigger size. It means that the denominator should be half, 1 to 25,000. This is very interesting. Consider the layout of the territorial regional chart, C115, this is not relevant, in which contour lines have a distance of 5 meters from one another. What are the contour lines? Are these lines? What is the difference in height between points A and B? Here you need additional explanation. Normally, to represent the territorial volumes, we use to imagine to cut then these volumes with a series of equidistant horizontal planes which intersect the real volumes along to these lines. Each line is to be considered as a kind of step. Each step is equidistant in elevation to all the other, from and to all the others. So in this case, it's just a matter of calculating if the first contour line, the first step, let me say, is at a level 0, the other is at the level 5, because the distance in elevation between the curves is 5 meters, and then the additional is 10, 15, and finally we get the exact question, which is the exact answer, which is 60 meters. Okay. And again, this is the exercise. We have points along a contour line. Another path, the path number 3, connected 2 points which are a little bit far in the representation, and 2 points, the path 1, connecting points a little bit closer. The question is, list the path 1, 2, 3 in ascending order of steepness. 1 minute. The distance is the same. This exercise is very important because any architecture is located in a real place. It's like a tree with the roots in the terrain. So you have to become able to manage the form of the ground. Sometimes architectures are totally underground, sometimes half underground, sometimes they are related with ground in a very poetic way, and you have to become able to understand. The answer is 2, because it is on a planar curve, all the points are at the same level, and these are like steps which are very far from one another, is less steep. This path, number 1, is connecting points across a path connecting very close contour lines, close each other. It means they are steeper. This path is steeper. Same question could be applied to the roof. Consider the following roofs characterized by horizontal eaves lines. Determine the only one where not every roof pitch have the same slope. Roof pitch is the top. You can calculate, and you realize that the only one is 5, because it has to reach the same level on the pitch in a shorter distance. The other apparently different is actually having the same steepness as the others. So the answer is A. Now, since we have 5 minutes, I would like to show some advanced tests. They have been prepared originally as exercise, but I will prefer to solve because they are really complex. This, for instance, given the floor plans above and their geographic orientation, north in that case, recognize the right elevations. Here we have some option. In Italian, sud means south, ovest means west, north means north, north means north, and est means east. So it's very easy to understand. So we have to understand which front is facing north, which front is facing south, ovest, and east, west and east. To do this, we consider that we have a ground floor and we have a first floor. Let's try to use drawing to solve a question about drawing. So first of all, the ground floor. The ground floor is related to a cutting level according to the blue line. The second floor is related to a cutting plane as the red one on the second level. Then you can start recognizing elements. This is the long front. Looking at the plan view, you can understand which is the long size and which is the short size. And this is the first element for the orientation. Then you recognize elements. These are related to the ground floor, so maybe they are here. These are related to the upper floor, and maybe they are here. And this front is south. Then let's go to the short fronts. Short fronts are those according to the other direction. And let's go to detect some relevant elements. First of all, this one, they are macro elements, very visible. And in the second level, you have these ones. And finally, you have this entry, this kind of entry terrace, very long, which is appearing below here. So it means that this front is facing the east side. So at the end, you have 1 is the south front, 2 is the west front from here, 3 is the north from the above, and 4 is hist, which means it is observed from the right side. Another challenging question is this. It's even more complex than the previous one. Apparently simpler, but more complex. The white part you see here represents the mass profiles of the walls in the vertical section and in the horizontal sections. So the question is, among the sections obtained with the cutting planes indicated in the plan view, it means A, B, C, D, find the one representing in the image, this one. Mind the direction of views according to the arrows. So it means that A is looking downwards, C is looking leftwards, B is looking rightwards, and B again leftwards. So you have to combine, you have to count the number of rooms, and you have to match the two sequences, and you have to understand whether and when they fit. This is very complex. The solution is this. The correct section is AA, but something doesn't, it thinks that something doesn't match, because you have an open space on the left here and you have open space on the right there. It was really difficult because you needed to rotate the plan view before. So this means that you have to activate your mental space simulator. And now you can put numbers according to the sequence 1 to 6 in plan and section, and you see that they perfectly match. About composition is the very last. Sometimes the object is split in two parts. One part is fixed, and the other, for the other one, you have several options. In that case, again, you have to understand which is the final figure you have to compose, in that case, a cube, and you have to focus. Sometimes with pencil, you can take the help of the pencil marking some references, in this case, the axis, X, Y, Z, and you recognize the faces. You put the axis on the other series, and you recognize faces, and you look for these faces on the figures below, and you immediately understand that the faces are two. The one with the star is the indented face which is hidden. It is along the plane ZX. So it is in this direction. And finally, you can exclude those who it is impossible they match, concluding with the only real option that is perfectly fitting the one above. In fact, this, then you go up, you go down, horizontal, horizontal, down, up, horizontal, horizontal, hidden, up, down, long, horizontal. And then here in the corner, you have this long part, and in that part, you have the small completing the composition. I think we don't have time. Okay, other questions are like this. Given these exploded faces, to which volume among those shown below it refers? In this case, 5. Or maybe what is the missing part, very similar to the one we have solved. I think we are almost on time. If you have any question, maybe you can ask me, and I don't know, the person in charge maybe can show the camera on me so that I can answer questions of the students. I don't know if we have any. I close now the sharing of my screen.
Good morning. My name is Maria Cristina Loi. I teach history of architecture at the Polytechnic of Milan. I graduated in architecture, and then I got my MA and PhD in the history of architecture. What I'm doing today, I'm presenting you the part of the text relating to general knowledge and history. And there is a difference with the other session of the test, since in this case, it is really difficult to give you one precise set of readings to do, because the discipline is so wide. And so what might be useful for you is to have a look at the questions that have been done in the last year's test, so that you can get an idea of what it could be. As I said, you will have both general knowledge, which means history, literature, music, and so on, and then questions relating to the arts, to the history of art and the history of architecture. Okay, this is the sequence of images that you might use to study. Okay, first of all, I wanted to make a very short introduction why there is this section in the test, and you will see that in the course of this your studies in architecture, you will find every year courses, classes on art, history of art, and history of architecture. And why? Why do you think you need to study this? I want you to think about this very important issue, and I introduce you a definition of architecture and therefore of the architect that was done by Vitruvius. You know that Vitruvius was a military engineer and writer who lived in the 1st century BC, and he was the author of the most ancient treatises on architecture that came up to our days. Of course, also the Greek wrote treatises, but Vitruvius' treatise is the one that arrived to us. This is a very famous representation of the Vitruvian Man by Leonardo da Vinci, and this is like a synthesis. It sums up what are the principles that Vitruvius was, explaining in order to try to explain the complexity of the discipline, which is architecture. So why history of architecture? And as I say, the answer we can find in the words of Vitruvius. He talks about architecture as a science. Here you see the original text in one edition by the editor Einaudi, publisher Einaudi in Italy. And as I say, the treatise is, the title is De Architectura, Libri Decem. It is divided in 10 books. And he talks about architecture as a science, which is composed by different knowledge like geometry, mathematics, astronomy, and etc. And so the architect has to be a scientist that has a lot of knowledge and in his preparation. And also the other very important concept that Vitruvius expressed is that architecture as a science consists of practice and theory, both these two aspects. And the architect, therefore, has to be versed no less in practice than in theory. And from this definition of architecture and architect, so from the 1st century BC, all the theory, all the theorists and all the treatises on architecture has moved from these concepts, which are really the basis of the idea of architecture. When in the Renaissance, with Leon Battista Alberti, the genre of architectural treatises started to flourish, and there were so many authors from Leon Battista Alberti on, we see that the starting point somehow is always this definition by Vitruvius. And this is just to give you an idea of the complexity of architecture, and also to explain why it is very important to study the history, and because not only to know things, but also to use the things to develop a critical spirit, and to understand that in the history of architecture we find recurrent issues, and then of course also every time as specific needs that the architect has to find a solution for. So this is a very brief introduction to the theme of architecture, and to explain why we do architectural history. Architectural history, these two names are interrelated. There is no architecture without history, and there is no good architect who doesn't know the history. Okay, so now I start with some examples. As I say, there is not a specific text or a specific program you have to prepare on. The very useful thing, we guess, is for you to look at the questions that have been done in the last years. I've taken from 2015-16 until last year, and try to make a selection of these questions so that you have a wide range of what it can really be. So I start with some general knowledge, and most of them are about history, and then literature, and then music. And not only, of course, I mean, you are coming to study at the Politecnico di Milan, so you are in Italy, so you will find for sure a lot of questions regarding Italian history and Italian art and architecture. But of course, also you will find a lot of questions that are related to an international context. And so you see, let's see some examples. As you can see, all the questions in the questionnaire have 5 answers. So you have to choose one of these. And in this presentation, the right answer is always the first one. But of course, in the test, they are mixed up. So it could be either the A, the B, the C, the E, and the D and the E. So, but in this case, just to show, to make it simple, the right answer is the A, the first one. So let's see some examples. The first one, which is the exact chronological order of these figures. So this is a typical question you have to put in the right sequence, either names of people, artists or historians, or works of art. And in this case, you see the sequence, the right sequence, you have a Roman emperor, and then Carlo Magno, Charles the Great, Federico Barbarossa, Lorenzo il Magnifico, and Emperor Charles V. You see, they are all mixed up in the 5 options. So what you do, you should start to find what you know for sure. If you have some, maybe you do not know exactly all the 5 persons, the years of their life of these all 5, but you might know 2, 3, 4 of them. So look thoroughly through these answers, and by exclusion, you'll find the right one. Remember, but this you know because this is explained in a general introduction, that you have a positive grade for a right answer, a negative for the wrong answer, and 0 for no answer at all. But of course, you can't not answer to all the questions because you have a minimal amount of answer to give. So, you know, the strategy is, of course, when you're sure of the answer, go straight to that. If you are not, you have to understand whether to try to find the right one. So give anyway an answer, or don't give any answer at all. So in this kind of questions, as I said, the most important thing is to look for what you are sure of. And the extremes, for instance, here are very easy. And so you can exclude, if you are sure, for instance, that Justinian is the first one, is the Roman emperor of the 6th century AD, you have only 2 possibilities, the A and the C. And so you have between these 2 to evaluate. And this, in this case, is also quite easy because Carlo Magno in the right question is the second one. In the third one is the last one. But you might remember that Carlo Magno became the emperor of the Sacro Romano Impero in the night of Christmas of the year 800. So he is for sure before the Renaissance of Lorenzo il Magnifico, and so on. So, you know, it takes some time, but please, as I said, focus and concentrate on what you are sure of. Again, let's see another question. To which year is the fall of the Western Roman Empire traditionally attributed? And again, in this year, these are all, of course, AD years, of course. And you might remember, as I said, the division between the empire, the Western and the Eastern Empire. And maybe, you know, the second date, 313, this is the important date that you might be sure of. This is the Constantine edict. And so you might exclude the second one, of course. And then again, you have to make some thoughts about whatever you can remember might help you to find the right one. You do not really necessarily need to all five of them. So it has to be also a logical process when you are trying to answer these questions. As I said in the beginning, since it's not possible to give you a precise program to study, I'm going to give you some hints about, you know, the process that you might apply to find the right answer. So let's see some other kind of examples. Which diplomat represented the Austrian Empire at the Vienna Congress? Again, this is history. Most of the European and international program of history in high school, you know, have this part of the recent history in the programs. So you might be familiar with the Vienna Congress, as well as the Yalta Conference, in which you see these three main figures, Stalin, Roosevelt, and Churchill, that participate and were negotiating peace at Yalta. Sometimes, which is more related to Italian history, is this question about the Aventine succession took place as a result of which event. And as I say, this is the assassination of Matteotti, so it's something related to Italian history, but it belongs to these historical moments in which the whole world was most part of the world was involved, as well as the Japanese attack on Pearl Harbor. And these are the years. In this case, you see the range is very close because we are talking about Second World War. So these are the years. So, but you have to remember more exactly when the attack took place. Again, a question on Italian history. The government of the Italian Social Republic was based and this is it was the Republic of Salò in the northern Italy. And what was the so-called question of Fiume about? And this had to deal with the sovereignty of the city of Fiume, which is the city at the border between Italy and Dalmatia. And so, again, this is, as I said, not only an Italian issue, is very much related to the context of the World War I. Now we move on a different field, which is literature, and this can span from the time of Dante and to more modern times like Shakespeare and more. So this is one of the most famous work, which is the Divina Commedia, the Divine Comedy by Dante. And in this case, there is also an issue of language. You know, most, of course, the text is in English, so you will find all in English, both questions and answers. In this case, though, the Divine Comedy, we use this translation because it is a typical name in which it is divided, you know, and they are called cantiche. The translation is might get in confusion with songs, but this is not exactly. In fact, you see the first one, which is the right one, is the 3 cantiche, or 99 chapters, or 12 books. These are more familiar names related to literature. And then canzoni, which is again a possible translation, songs, and canti. So these are the cantiche, canzoni, e canti are the specific Italian names of the division of the Divine Comedy. So the right question, the answer is the A, so in 3 cantiche. The next one is related to William Shakespeare, and here is a list of 5 of his 4 of his most famous works, and only the first one is not by him. And so again, if you do not know the author of Lady Windermere's Fan, Oscar Wilde, you can you might for sure know the other ones that instead are by William Shakespeare. So this will make it very easy to find the right answer. Again, on the literature, these 2, what is the name of the literary movement born in France in the second half of the 19th century, under the influence of positivism, which dictated that the experimental method should be applied to the writer's work, and this is naturalism. We are in a chronological area in which naturalism were, expanded to different fields of the culture. Which of the following novelists was also a mathematician? Everybody, I think, knows Lewis Carroll, and he was actually also a mathematician. You see, some of these are more obvious as answers, some are more probably difficult, probably complicated. But again, I suggest you always to check on the alternatives, and so you might be very much helped by that. Which physicist won the Nobel Prize in 1922 for his studies on the structure of the atom? And this is again something that you might have studied in high school in the class of physics. So Niels Bohr. It might be a bit confusing because then there is the atom on Bohr and Rutherford. That was another study, but the Nobel Prize was only by Bohr. This other question on the outskirts of which city is CERN located, there have been a lot of talking about, and so the city is Geneva. Let's go to music. To which opera by Giuseppe Verdi does the famous choir Va Pensiero belongs? And most of you should know that Va Pensiero is this famous choir by the Nabucco by Giuseppe Verdi. These are all operas by Verdi, all very famous, and Va Pensiero is one of the most famous ones. So this shouldn't be that difficult, also for foreigner students. And this one is about the emancipation movement for women and where it started, this movement of the suffragette. And this was in the United Kingdom. And of course, it spread all around the world, even across the ocean in the USA, but it all started with the suffragette in the United Kingdom. Now we go to this more history of art and history of architecture field. Most of these questions will show also a picture, an image to help you. Not necessarily though, but most of them. So I have made a selection of this. Some have to do with terminology, because you need to know the terminology, the nomenclature, the terminology, the vocabulary of architecture. So what is a rose window? A rose window is a large circular window in the middle of the facade of many churches, as the first and right answer says. You for sure have seen a lot of these churches that from the Romanesque and through the Gothic time, and also after, which present this very big circular window on the facade. Sometimes it's the main source of illumination to the central nave up until the apse of the church. So in this case, the right answer is the first one. And, you know, in this case, if there is a picture, this will help you, of course. I have put these two images in order to help you to understand that we are talking about the circular window in the middle of the facade. And in case there is not an image like this one that suggests you the right answer, you might again think rose window. You might be helped by the fact that it is a window, and therefore the word window is in the answer. So you know there are different ways that in which the answer is suggested. In this case, we have this kind of question in which you have to find the chronological order. Before was with the historical figures, now is what artistic movements. The classicists, impressionists, expressionists, and pop art. In this case, you see, even though you do not know the exact sequence of the four of them, but you know that pop art for sure is the last one. So again, look at the five possible answers, and you will find only the first one and third one with pop art at the end. And so again, try to, you know, think about only these two, so to get less confused. And I hope that you will remember that neoclassicism is becoming before impressionists and expressionists. I repeat, this is only a series of examples, so this will not be the questions, but this is the typology of the questions that you will meet in the text. In the following list, famous museums are matched with the city where they are located. Which match is wrong? So in this case, is another typology. You have to associate one name and one place, for instance. In this case, one museum, famous museum, and the city in which the museum is located. And in this case, again, the right answer is the A, Hermitage in Moscow. Again, you might, in this case, be helped by the names. Prado, Spanish name, so is in Madrid. Mugello is in Italy, is in Florence. And so, you know, you might also be helped by this, as I say, different way of thinking about the right answer. Again, with a picture, this is one of the most famous sculpture that you might have seen in your art books in high school. And it is the famous Discobolus, which was sculpted by Mironi. In this case, you see a plate with the main typologies of Greek temples. So the question is, what is the name of the cell of the Greek temple? So you have this five answers: naos, pronaos, opistodomos, peristesis, and shaft. The name of the cell is naos. In Latin is cella, and in Greek is naos. Sometimes when we talk about antiquity, you can find both the names in Latin and Greek. Here we are talking about the Greek name naos. The Domus Aurea was built to be the residence of who was a figure who wanted this huge residence in the valley between the Palatine and the Aventine, and this was Nerone. The Domus Aurea, for instance, is a very famous, this only part of his enormous project was realized, and there have been recent excavations on the Domus Aurea. So very recently, you might have find some articles on the news about the Domus Aurea. And so also to be updated with new discoveries, new excavation campaigns might help you to find the right answer. This is a plan of a church. Sometimes, you know, there are familiar images that we know from the very first years of school. This is a typical Gothic church. There are typical elements that help you to recognize that this is a typical Gothic church, because it has rectangular base with vaults and has this configuration of the choir with all these chapels. And so this is a typical plan. And then you see all the vaults here, the projection, these signs are the projection of the vaults. So you see this very complex structure is the typical plan of a Gothic church. Also in terms of language, in this case, we find that we recognize immediately the style of this cathedral, which is in central Italy, in Siena. This is the Gothic cathedral because we see the presence of very typical elements that belong to the Gothic. And do not be, you know, confused by the fact that, for instance, here we find some hemispherical arches which are typical of the Roman and Romanesque architecture, whereas in the Siena, in the Gothic style, you find ogival arches. But sometimes, you know, churches and the facade, especially of the churches, were completed in different phases. So it might be that there is a coexistence of elements that belongs to another phases, but when you see the final result, in this case, we can for sure affirm that this is a Gothic church, or at least that it was completed in the Gothic time. This is another question which, you know, require your knowledge of chronology. Who participated with Brunelleschi in the competition for the panel of the door of the baptistery in Florence? Was this competition, and Lorenzo Ghiberti won. This is one of the most famous work of one of the most famous architects of Italian Renaissance, Leon Battista Alberti, is the so-called Tempio Malatestiano, that was the Church of San Francesco in Rimini. This one is one of the most famous architecture, the Villa Rotonda by Andrea Palladio, that you might for sure know. And this is the plate from his treatises on architecture, the 4 books of architecture, in which we see the plan and the facade and section of the Villa Rotonda. Another question about attribution of a work. Who is the author of this sculpture? Gian Lorenzo Bernini, Michelangelo, Fidia, Maron, and Brunelleschi. In this case, you might remember, if you do not remember exactly who was, but you remember that here there are a lot of themes that are typical of the Baroque art, and so therefore you can immediately associate this sculpture with Gian Lorenzo Bernini, who is one of the first generation architects of Baroque. Also about the Baroque, which is the name of this church, I put the name in Italian. Sometimes the names you might find in the translation in English, but mostly in the Italian name or the name, the original language. Sant'Ivo alla Sapienza, San Carlo alle Quattro Fontane, Sant'Andrea al Quirinale, Sant'Andrea della Valle, San Pietro. And this one is the interior view of the vault of the Church of Sant'Ivo alla Sapienza by Borromini. Another dome, here in the 2nd generation of the Baroque architects, and this is also famous by Guarino Guarini, the Chapel of the Holy Shroud in Turin, because if you have seen recently, it was open again. It was closed, this chapel, because of fire that destroyed part of the architecture. So it had been closed for many years. and it has been recently opened. So therefore, I mean, if you have if you look at the news and you read about newspapers and magazines, scientific magazines on the arts and the architecture, you find a lot of information that might be really useful for you. Here, you know, the options are all in the world of the late Baroque, of the Torinese Piedmont Baroque, but in this case, you have to be very precise and to recognize this image. This image is very famous, which is the style of the Tassel House by Victor Horta, the Art Nouveau. This is the typical, you can recognize by the kind of curvilinear elements. And this one, I'm going, as you see, in a chronological order because of the history issue. You know, it's important to follow the chronological order. So the work shown in the picture was designed by Le Corbusier. This is one of the most famous work by Le Corbusier, and I assume that most of you will know it. The Bauhaus was founded by Walter Gropius. I go a bit faster now. And this was, I'm sure nobody will fail to give the right answer to this, who is the author of the project of the Guggenheim Museum in Bilbao, Frank Gehry. A few pictures now of paintings. The author of the given painting is Canaletto. This is a typical image of a typical view of Venice, of these schools to which Canaletto belonged. These are also very famous views. Who is the author of this opera? Again, you might exclude easily Magritte, Modigliani, and Monet, but also Braque. I mean, this is so typical, you know, image. Mondre was the author of a series of works of art on this, working on this system of colors and composing areas, which the main colors and the white and the black lines. So it's like his signature. And in a way, also Paul Klee, who is the author of this painting, is quite recognizable because of this use of the color and this style of his not figurative part of his work. And this is the last image. The work represented in the figure is, and in this case, Oskar Kokoschka is the author. In this case, you have the name of the author, the title of the work, and the year. And in this case, you will find a lot of information. So you might be, you see there in the span of half century more or less. And so in this case, you have three different information: name, title, and year. And these three elements might contribute to find the right answer. I hope that I gave you a quite clear idea of what test is. You might use any manual just to have a chronological line to follow in the arts and in the history of arts and architecture. But as I said, also it is very important to read, to be updated with new discoveries and restorations and archaeological campaign, you know, all this kind, and work a lot of images, because with images you are coming to a school of architecture, and we will work a lot with images and you know, drawings, pictures, and so this will help you to memorize and to be able to interpret either a drawing or a work of art or of architecture. Thank you very much.
I suggest you to use any handbook for secondary or high school about drawing, technical drawing, descriptive or projective geometry. Any handbook is okay. We have other sources. On the Polimi website, I have written this name in the public chat. If you scroll, you can find it. There are some questionnaires, some questions taken from the former questionnaires. There should be another interesting archive on the web page Universally. I have written this name in the public chat as well, so you can find this name as well. If you search in the website, in the section dedicated to architects, related to the past editions of the course, you can find several PDF documents, including the Italian and the English versions of the questionnaires. These questionnaires are related to all the questions, all the matters listed, which are not only drawing, but also history and logic, maths, and so forth.
I want to add, sorry, because in my case, it's even more difficult to give a text to answer. So I wanted to ask you, because I know that it's registered, and as I say to all students before, it's difficult to give a precise text. I prepare in my presentation, I added some more questions, because some of them they can find on the side, but only few in English. Most are in Italian. In English, there is only a little bit. I prepared more materials, so if you want to, I can add to the presentation, because I see that many students are asking this, and they say that most informations are about Italian and so on. So in order to help the foreigner student in this so wide, so big part of the test, let me know if I can add a few images to my presentation, if I can send the complete PowerPoint, and so that I will also, put the English translation in those 3-4 that weren't translated by mistake. So, because as I said, it is difficult. And then there are a lot of students that are asking about problems with visa, and one student is asking if he can move the date of the exam. Of course, it is not possible. And I think some questions that they are asking, they have already been answered in the first part of our presentation. How many questions for each part, and how many points you get for every right answer, wrong answer, no answer. So all of this is in the first slides, so they can find it.
At this point, Maria Cristina, some students are asking what is to be done in front of a question where you are hesitant. In case you are hesitant, it is better not to give answers, because a wrong answer is negative marks, while no answer is 0. Positive answer is positive marks. Of course, we have to answer a certain minimum number of questions to be admitted.
Exactly. Yes, I said make up your mind to understand, because if you're hesitant, it's better not to answer. But I don't want them to think that then they do not answer to.
There is a minimum number of questions they have to answer, otherwise they are not admitted as well.
Yes, exactly. And then I say this multiple choice sometimes, especially when you have, you have 2 things that are sure, so you base on that 2 things that make you stronger the decision. So, there are different devices. And then they are asking, okay, one part that I try to explain, because we are in Italy, so also some of the historical questions, not all of course, but many relates to history of Italian history. So, they say, what if we haven't done this in school? But of course, this we can't answer about that. I try to put the different typologies of questions, so that I was trying to show that some regards Italian history, but most of them are about international, you know, World War, Second World War, and you know, more international issues, or at least European. Oh, here is Professor Vianello. He says, "I'm here."
Okay.
Is that okay?
Yes.
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 Okay. So good. So now my name is Maurizio Vianello, and I'm here to introduce you to the part of the test which deals mainly with mathematics, physics, and logics. There are a few questions. Actually, it will be 8 questions between 5 in mathematics, let's say 3 in physics, and then a bunch of questions about what they call logics. Okay. So what you see now is just a short example, a few short examples about questions which were present in the last year tests, in the test which was proposed to last year's students. This was included in the part of logic. I would say it's not always clear to me why something is belongs to the field of logic rather than the field of mathematics. But anyway, that's what the choice they made. This is what the choice they made. So you can read here. When a mass of water, indeed, this is mathematics actually. When a mass of water passes from a liquid to a solid state, it increases by 1/11. When this same mass of ice passes from a solid to a liquid state, it decreases by. Choose the appropriate answer. So rather than my presentation, unfortunately, I prepared with another technique, and here now I can't really write on the screen. But you see, you have something, if you increase something, x is divided into 11 parts. The 11 means you think that you have 11 parts of some quantity x. If you increase by one of those parts, 1/11, okay, you get something with 12 parts. You see, on the top, it is 1. On the top, I see, maybe you see my mouse going around here. So 1/11 on top. So y, the new quantity, which is y, is the previous quantity x multiplied by 12/11. Why? Because you take x, you look at this line, you have x, which becomes x plus 1/11 of x. That's the idea. Which means, of course, you collect x, you get x times 12/11. But then when you go from y, you go back, how much, what happens? From y, you go back to x. But x is, of course, is 11/12 of y. You see, because y is 12/11 x times x, and then x is 11/12 times y. But what is 11/12? 11/12 is 12/12 minus 1/12. So you go back from 1 unit, you go back, you take away 1/11 parts. So you decrease by 1/12. And then this is indeed, we go back, the correct answer is 1/12. You go back, here the trick, some people that made mistake probably, or go and say, well, I go up by 1/11, then when I come back, I go down by 1/11. But that's not true, because when you go up, you have more things. And then that's the trick. That's the trick. The tricky part was to distinguish between A and B. And this is something that in various forms, this is a kind of question, I can tell you that in many ways, in different forms, it appears frequently. So you just try to learn this, because this is something that might be there again and again. I've seen this many times in my years here at the Politecnico. I've seen this. This is logic, but actually it's a system of equations. All this with mathematics. Alice and Giorgio do their shopping, offers 1 gadget for every 30 euros. Notice that the 30 euros will not enter. So it's there, but it's useless. It might happen. It might happen that some data is there just to create some confusion, because the data is not used. If you know that the total number of offered gadgets is 24, and that Giorgio needs twice Alice's gadgets to complete the collection, and that Alice has 4 more gadgets than Giorgio, how many gadgets does Alice have? Now let's call G and A the number of gadgets that Giorgio has, and that A the number of gadgets that Alice has. There is a total of 24 gadgets down there in the shop. So, but what is the number of gadgets that Giorgio G needs to complete the collection? Is 24 minus G. Okay, 24, the total, minus the number that he has. But that's twice the number that Giorgio needs twice Alice gadgets to complete the collection. 24 minus A is the number of gadgets that Alice needs to complete the collection. 24 minus the number that she already has. And the number that Giorgio needs, 24 minus G, is twice the number that Alice needs. So we have one equation between two unknowns. The other information is that Alice has 4 more gadgets than Giorgio. So Alice, A is the number of gadgets that Alice has, is 4 plus the number of gadgets that Giorgio has. Here you see it's a very simple system of 2 equations in 2 unknowns. That's the way I would have done this, without using too much, thinking too much. It's just 2 equations in 2 unknowns. You transform the problem into a system of equations. This is very easy. You plug A from the second one into the first one, you subtract, and then of course this is a very simple system. We assume that you are able to solve this, and then you get 20 and 16. So, and then it's true, Giorgio has 4 gadgets less than Alice, and Alice needs 4 to complete. Giorgio needs 8 because total number is 24. So Alice needs, so you check at the end, you check again that what you've done is correct, is in agreement with the data. Okay, so the correct answer is Alice has 20 gadgets, A to A. Well, here the answer is always A because it's a technical stuff. Usually, of course, the answers are mixed up, so you don't know which is the right one. Otherwise, it's not that this. Well, this was a bit. It took some time. You have to think a little bit. So this was. I don't say this is straightforward. It doesn't take that much, but it takes some questions are somewhat expensive in terms of the time it takes to solve them, to give an answer. This is very easy. I mean, having drawn an isosceles triangle ABC, so I draw ABC, so AC is equal to CB, so the 2 sides are equal, and then we consider another triangle ABD with the same base and its vertex on the extension of 8CH. So you take 8CH and then you extend this and go up, and the 8DH of ABD, of ABD, the 8DH or DH is twice CH. Basically, we get 2 triangles with the same base, but the height of the bigger triangle, or the right triangle, is twice the height of the smaller triangle. So, to which fraction of the area of ABD does the triangle ABC correspond? It's obvious that the area of the right triangle is twice the area of the small triangle. So the black triangle, the area of the black triangle is 1/2 the area of the bigger triangle. Okay, very easy. If you just draw every time, try to draw, because this is going to be helpful. This is almost trivial. If you draw correctly, you just see what happens. It's trivial. The base is the same, the height is twice, so the area is twice. And that's very, very easy, very easy. I would say that once you draw the picture, this is very, very easy. Next, we go to the next one. This is logic. I would say that this is also not logic, because to me this seems like mathematics, but we go to the question, which was number 19, and then this is pure logic. All 4th-year architecture exams are very difficult. No very difficult exam has less than 6 credits. Which of the following statements is unquestionably true? Well, of course, all fourth-year architecture exams are very difficult, but no very difficult exam has less than 6 credits. So when you read this, all the fourth-year architecture exams are worth at least 6 credits, of course, because if they tell you that they are all very difficult, no very difficult exam has less than 6 credits, it means that all fourth-year architecture exams are worth at least 6 credits. This is, once you read that, you understand that's the right one. You can go through the rest, but it's quite clear since there is only one correct answer. There is only one correct answer. This is the right one. It's not useful to go through the other answers. When you try to read, you find something, you listen, and you read them. Once you find something which is in full agreement with what is written, with the premises, then that's it. That's it. Now another one. Now we go to math and physics. Math and physics. Well, this is on a diameter on the diameter AB, which is twice the radius, 2r, of a semicircle. Establish point C anywhere, but not on the extremities, and create 2 semicircumferences of diameters AC and CB with this semicircle. The ensuing figure, limited by the 3 semicircumferences, known as arbelos, was studied by Archimedes. This is a famous shape, the arbelos. Maybe we have seen that before, maybe no. What is the measurement of the perimeter of the arbelos? Okay, so what is this arbelos? Well, you draw a semicircle, and then you have the diameter of length r plus r. And then you choose a point anywhere here. Let's say you choose a point more or less here. And then what you do, you draw one semicircle. Let's call this point C. You draw one semicircle with diameter AC and another semicircle with diameter CB. Then you draw something like this. You see, one here and one here. So you have 3 semicircles in the end. I've drawn this on the next page, and that's what it is. You see, you draw C. The drawing is important. You have to be able to translate ideas into shapes, into a drawing. So you have C here. You don't know what C is. C is a distance, let's say X from A. So AC, we call it X. CB, we call it 2R minus X, because the total diameter is 2R. So the diameter of the distance between C and B is 2R minus X. So what is, and the arbelos, the so-called arbelos, is the piece of the plane, the region of the plane, which I've shaded slightly in red, you see? So the question is, what is the perimeter of that region? Of course, there is pi r, which is the bigger side, the semicircle, the bigger semicircle. The length is, of course, pi r. Pi semicircle is pi the radius. What is the length of this? The smaller semicircle is pi times the radius, but the radius of this is x over 2. And what is the perimeter or the length of this semicircle of diameter CB? It's pi times the radius, but what is the radius? Is 2r minus x over 2. And then the total perimeter is pi r plus pi x over 2 plus pi 2r minus x over 2. But pi x over 2 and minus pi over x over 2 will simplify, and then you only get pi r plus 2 and 2 will simplify, plus pi r. So you get 2 pi r. So the total perimeter is just equal to the length of the whole circle, 2 pi r. There is another way to solve this, which is interesting property, of course, but there is another way to approach this, is to notice that they will not tell you where C, the point C, should be placed. So you may think, if the question is correct, the answer will not depend on the position, on the point, the precise point, the precise location of point C. It doesn't depend. I can choose C very close to A, in the middle. I can choose C very far on the right. So, because otherwise the answer would depend on C, on the position of C. They are asking me, what is the perimeter? And they do not tell me where I should place C. So I can choose the position of C that I like. So I could, for instance, put C in the middle. Then it's much easier to compute the length of the total semicircle, the semicircle on the left and the semicircle on the right. Very easy, because of course you don't need to use X, okay? So I used X, but then I found out that the answer does not depend on X. So if you think you are more astute, let's say more astute, you might say, well, since the answer does not depend, I see here that the answer, whatever the answer is, does not depend on the position of C. So I put C in the middle, and then I compute, and then I get the correct answer very fast, faster than in this way. Or maybe I can also think, if I push C towards A, I notice that one of the semicircle will become smaller and smaller, basically 0, and the other one will become very, very close to AB, to the semicircle with diameter AB. So in the end, I understand from that the total length of the perimeter of the arbelos, excuse me, is 2 pi r. That's another way to approach this, okay? Answer, the idea is the answer does not depend on X, on the position of C. So I choose the position of C which is more comfortable for me to do the computations, okay? That's something you should keep in mind. This is much more straightforward because it's which are the solutions of the equation sinus of x plus cosinus of x equal 1, when x is between 0 and 2 pi. X, of course, is measured in radians. Okay. So it's very, of course, if it's enough to know what is the sinus and the cosinus of some important angles. If you put 0, you get the sinus of 0 and cosinus of 0. But cosinus of 0 is 1, so 0 plus 1 is 1. It's okay. So 0 works. So you rule out the last answer, because the equation has no solution. No. X equals 0 is the solution. And then x equals pi over 2. Yes, because the sinus of pi over 2 is 1, but the cosinus of pi over 2 is 0. So 1 plus 0, 1. So this works. Would B work? X equals 0, you already know that it works. But let's try x equal pi. X equal pi, sinus of pi is 0. Cosinus of pi is minus 1. So 0 minus 1 is not equal to 1. Wrong. Of course, you don't have to go through all of them, because you know that the solution is only one. You go through, and then when you find the solution, you stop. If you want to be cautious, you just check the others. But this is straightforward. Of course, for doing this, you should be able to know, you should know very basic ideas about trigonometry. Otherwise, if you do not know what the sinus or the cosinus is, you cannot answer this. But if you know, this is very easy. Just plug in and check. You don't need to solve the equation. You just substitute what they give you, and then check what works and what doesn't work. Okay, let's go on. This is more complicated. I would say this is more difficult. What is the ensemble, which is the set? I don't know, here the translation was a bit questionable, because everyone would say in English, what is the set of the real solutions for inequality, that inequality? Well, look at the inequality. 2, the square of the logarithm of x plus the logarithm of x minus 1. Then what you do? You notice that this looks like a second degree equation. It is a second degree equation. If you call logarithm of x, you call it z, you put z equal to the logarithm of x, this will become 2z squared plus z minus 1. which means 2z squared plus z minus 1 less than 0. So, and you need to solve this. Remember, after that, you solve, you find z. And once you know z, you go back to the logarithm, okay? Because if z is the logarithm of x, it means that x is e to the z power. So let's find z. Let's solve this inequality. First of all, you solve the equality. You put this equal to 0. And then what is? Well, here it's important that you remember what is the rule, the formula for solving second-degree equations. You must know the rule, the formula for solving second-degree equations. If you use that formula, you get that z equals minus 1, because the coefficient of z is 1, you have to put minus the coefficient of z, plus or minus the square of the coefficient of z, which here is 1, minus the product, minus 4 times the product between the coefficient of z squared and the last term, okay, the last addendum in the equation. So you just go back, check. This is important. You must remember the formula for solving second-order equations. This will be there. Most of the times, there will be somewhere a second-degree equation. So you solve it, and then 8 plus 1 is 9. The square root of 9 is 3, and you get minus 1 plus or minus 3 over 4. And then you get minus 4 over 4 is minus 1, or minus 1 plus 3, which is 2 over 4, which is 1 over 2. So the solutions are 1 over 2 and minus 1. But you want to find the values for which this quantity is less than 0. It is 0 at z equal minus 1, and at z is equal 1 over 2. But this is a parabola, because you know that if you represent this function, the function, quadratic function in the given variable z, then you can draw this in the z plane, z here, and this is the value of the function, as a parabola with this pointing upwards. It's a parabola pointing upwards. So the z, which will give you a negative value of this polynomial, the z for which this will be negative, are always of z, be minus 1 and 1 over 2. But z was the logarithm of x. So you know that the solution is logarithm of x between minus 1 and 1 over 2. Then you take this to the, you take e2, the quantity, e2 minus 1, less than e2 logarithm of x, less than e to 1 over 2. But e to the logarithm of x is x, so you get x between 1 over e and 1 and e2 and the square root of e, which is this one, the first answer, okay? And this was somewhat more difficult, because you have to understand that sometimes you need to change the variable in an equation. So if you look at this and you consider this as an equation in the in x, you don't go anywhere. You do not go anywhere. But if you remember that you can put logarithm of x equal to z, and this way you get a second order inequality, because this is second order, not equation, but inequality, and then you remember how to solve second order inequalities, then you find the solution. Of course, there are other ways to approach this. It's not so, because for instance, you can rule out some of the possibilities. For instance, x minus less than minus e is not possible, because you know that the logarithm, you can compute the logarithm only of a positive number. So there is no way you can compute the logarithm of a number which is less than minus e. There is no way that you can plug in the logarithm of a negative number. So e is for sure wrong. And then the others is more difficult to rule them out. You have to think a little bit. The straightforward way, if you don't have some, of course, you can play around. There are many ways to solve this. But I would say if you are knowledgeable enough about second degree equations, inequalities, second degree inequalities, you just follow this, and then that's what you get. It takes some time, so this is not so trivial. Okay, this is another approach. This is another approach. First of all, we can rule out this is just to tell you how this could be done. Notice that if you plug in x equal 1, the logarithm of 1 is 0. E to the 0 is 1. So the logarithm of 1 is 0. So if you plug in 1, you get 0. 2 times 0 plus 0 less than 1. From this, you conclude very easily that C is wrong. The empty ensemble would be the empty set. This means that there are no solutions. But you have just found a number which will satisfy the inequality. X equal 1. 2 times 0 plus 0 is 0, which is less than 1. So x equal 1 is a solution. So it's not true there is no solution. C is ruled out. You rule out C. And then what about B? But B is between x between 0 and 1 over e. But 1 over e is less than 1, of course, because e is 2.7 something. So 1 over e is less than 1. But then it would seem from B that 1 is not a solution. All x between 0 and 1 over e. But then 1 is not there. But then you know that 1 is a solution. So this is wrong. So B is not the right answer, and C is not the right answer. D, you can rule out, no, E, you rule out E because there is no logarithm for numbers which are less than 0. So E, you rule out E. And then there is another thing that you might remember, that if you put E, the logarithm of V is 1, because E to the 1 is E. So the logarithm of V of E is 1. So you have 2 times 1 plus 1, which does not satisfy. So from this, you see that when you put here x equal E, the inequality is not satisfied. But D will tell you that all positive value of x will satisfy the inequality. But you just found out that x equal E will not satisfy the inequality. So you know that D is wrong too, without so much faster if you think. So this is wrong. All of them are wrong except A. So A must be the right answer. And it is the right answer. You see, this is another approach. It's enough to know that three things: that there is no logarithm of a negative number, that the logarithm of 1 is 0, and the logarithm of E, when x equal E, the logarithm of E is equal to 1. From the knowledge of this, you can avoid going through all those computations. Okay. So there are sometimes two approaches. One is more astute, if you think about that quickly. Here there are 3 straight lines, okay? These are the equations of 3 straight lines. And what happens? Well, what happens to them? They are all pass through the same point. They are all orthogonal in pairs, etc. First of all, we write the lines in a more explicit way. So you write y equal x. That's the first one. The second one is, look up there, 2x minus y minus 1 equals 0. So you take y on the other side, and you get y equal to x minus 1. The last one, you need to divide by 4 in order to get this in the normal form. This is called normal form of the straight line, of the equation of the straight line. Y is equal to x over 4 plus 3 over 4. You take minus x minus 3 on the other side, divide by 4, and you get this. So they all pass through the same point. Is not obvious. You need to check. But they are all orthogonal in pairs when 2 straight lines are orthogonal. When the angular coefficient, the product of the angular coefficients of the 2 lines is minus 1. Just the angular coefficient of the first line is 1. The angular coefficient is 2 here. What's the angular coefficient? The angular coefficient is the coefficient which is in front of x. When you write the expression, the equation of a straight line through the normal, so-called standard form, the normal form. And then you notice that they are not orthogonal. The first line is not orthogonal to the second one, because the product, you can draw them if you wish, and you see that they are not orthogonal. So B is wrong. They are parallel. When two lines are parallel, when they have the same angular coefficient. But here it's quite clear that here the angular coefficient is 1, here the angular coefficient is 2, here the angular coefficient is 1/4. So they do not have the same angular coefficient. They are not parallel. At least one straight line has a negative angular coefficient. No, the angular coefficients are 1, 2, and 1/4. All of the angular coefficients are positive. So D is wrong. The second and third straight line both intersect the negative semi-axis of dots, because in the copy that I had, there was a piece missing here. So this was wrong, but I can't tell you precisely why, because there was a misprint. I don't know. I hope this was not in the copy given to the students, but E was incomplete, because the PDF I could find didn't conclude this sentence. The sentence was not completed. But anyway, let's check that they all pass through the same point. It's not difficult, because you say, those are the straight lines. It's very easy. Y equal X. I'm looking for an intersection. So a point which satisfies all the equations. Y/X, I put this Y equal X in this Y equal X in the second one. So I get X equal to X minus 1. The second one, the third one is X equal X/4 plus 3/4. But from the second one, you get 2x, you take X on the other side, and then the minus 1 on the left side, and you get X equal 1. From X equal 1, you get that also Y is equal 1. You have to check that also the third equation is satisfied. But when you plug 1, where there is X in the third equation, you get 1 equal 1/4 plus 3/4, which is 3/4 plus 1/4 is 1 equal to 1. So the point 1, 1 satisfies all the equations, all of them, 3 of them. Because if you take 2 of them, of course, if 2 lines are not parallel, they will meet at one point. So it's quite obvious that for each pair of lines, you get the point of intersection. What is not obvious is that, which is not true in general, that 3 lines will intersect in a common point. Usually, if you draw 3 lines, they do not they intersect pairwise, 2 by 2. 2 intersect. There is intersection between 2 of them, between the other 2 and between the other 2, but not all of them. So this was the right answer. That's physics. So you have the Cartesian plane, and you have charge Q1 placed on a negative charge, you see. So you have, this is you have to remember here, you need to remember a basic fact about electromagnetism. You need to remember a basic fact, which is, as we check now, what is this fact? Well, what is the question? The question, you have 3 charges, Q1, Q2, and Q3. Q3 is placed at the origin, and it is positive. Q3 is at the origin. If you read, Q3 is at the origin, and the quantity of charge in Q3 is 10 to minus 6 Coulomb. You know, the amount of charge is measured in Coulomb. Coulomb. It's written C. C means Coulomb. And it's negative because there is a minus. I didn't write the minus here because I just wrote the minus, a red minus. So Q3 is, Q1 is minus, sorry. Q1, there is a minus, but I put the minus in front. So Q1, which is located at 3 units from the origin, is minus 4 times, you can read it. Q2 is placed up there. It's positive. You see there is a plus. It's a positive charge. And Q3 is down at the origin, and it's a positive charge. So we have 2 positive charges, 1 negative charge, and they are placed 6 units, 3 units. What is 1 unit? The same unit, centimeter. So this is 6 centimeters and this is 3 centimeters. So they form the vertices of a straight triangle, okay? We know the amount of charge Q1, Q2, and Q3. We know the position of the charges. We know that we should take the Coulomb constant K, the value of the Coulomb constant K, to be given by 9 times 10 to the minus 9. Newton times meter square divided Coulomb square. This is a fundamental law. What is the question? The question is, what is the force, the intensity of the force acting on Q3? Because of the charges Q1 and Q2, there is a force acting on Q3 because of the action of Q1 and Q2. There is a force acting on Q3. What is this force and what is the intensity of the total force? The intensity of the resulting force acting on charge Q3. How do you do that? It's impossible to solve this, to answer this question, if you do not remember that whenever you have 2 charges, 1 and 2 or 2 and 3, whatever, you have 2 charges separated by distance r, the intensity of the force acting on each one of them, the force acting on Q1, which is equal and opposite to the force acting on Q2, is given by K, which is the Coulomb constant, times the product of the charges divided by the square of the distances. You remember that, you have to remember, this is very important, that you have to be careful here, because the K is given in Newton times meter square divided by C square. But the distances here, this distance is 3. It is not 3 meters, it's 3 centimeters. So you have to translate this into meters, otherwise you make a mistake. And the 6 also, it's 6 centimeters. So is 0, this one is 0.03 meters, and this is 0.06 meters. You have to use meters, because the constant C, the Coulomb constant C, is given in terms of Newton, meters, and square Coulomb. So what you do? The force, you have to remember also that this is the intensity of the force. The force, if the 2 charges have opposite sign, the force will be attractive. If they have the same sign, plus and plus or minus and minus, the force will be repulsive, because this equation up there will give you the intensity of the force. But in order to deduce the direction, the orientation of the force, you need, that depends on the fact that the 2 charges are opposite or same sign. Okay, so let's apply this. So let's take 1, 3. Q3 and Q1 is 3 centimeters. Go back, you see, 3 and 1. 3 what? 3 centimeters, which is 3 times 10 minus 2 meters. So you use this formula. That's the force between 1 and 3. The force between 1 and 3 is K. Q1, Q2, well, Q3, of course, you plug in the correct, you use the same formula for 1 and 2 and 2 and 3. Okay, you remember that you need to divide by the square of the distance, but the square of the distance in this case is not 3 to the square, it's 3 times 10 minus 2 to the square. And for charges 2 and 3, the square of the distance is 6 times 10 minus 2 to the square. Of course, there is a lot of simplification. This is K. They tell you that you need to use K equal to 9 times 10 to the 9. So you use K, the K here is 9 times 10 to the 9. And then you plug in, it's very easy, because of course, in the end, once you know how to use the formulas, the computation, everything will simplify. You get 4 and you get 3. But remember, what is 4? 4 is between the intensity of the force between 1 and 3. And 3 is the intensity of the force between 2 and 3. Here I should have written to be the norm, and this is the intensity of the force. I didn't write it down, but this means the intensity of the force. So here it is. You have a plus and minus. So between 1 and 2, the force is attractive. So it's a 4 Newton attractive. So the force on 3 points towards 1 because Q3 is attracted by Q1. 4N horizontally pointing to the right. And between 3 and 2, well, they have the same sign because Q3 is positive, Q2 is positive. So it's repulsive. So Q3 by an amount 3N is pushed farther away from Q2. So the force that Q3 receives from Q2 is pointing downward, 3 Newton downward. Why? That Q3 receives from Q1 is 4 Newton pointing to. But the question is what? The question is the intensity of the resulting force. So it's not finished because you have a force 4N, 4 Newton to the right. You have a force 3 Newton downwards. So what is the total force? The total force is not force plus 3 because these are not numbers. It's not 4 plus 3, 7. That would be wrong. It's the diagonal because how do you sum forces? You draw the forces and then you draw the diagonal of the parallelogram with the two forces which has as its sides the two forces. So 4, but here they are orthogonal. The forces are orthogonal. So you just draw the diagonal of a rectangle. But in this rectangle, the upper side, the length of the upper side is 4. The length of the downside of this left side is 3. So what's the length of the diagonal? Is the square root of 4 plus the square root of 3 over the square root of the square, no, the square root. The square root of the square of 3 plus the square of 4. But 3 to the square is 9, 4 to the square is 16, the total is 25, the square root of 25 is 5. So this is the correct answer, okay, 5 Newton. This is, it took some efforts. Of course, there are many other approaches. Well, the 7 Newton is typical of the people who do just the 4 plus 3. One force is 4, the other force is 3, so the sum must be 7. That's the reason for which they put answer 7. And for the rest, I think you can rule them out because of a question of magnitude. C is wrong for sure because it's the magnitude, the intensity. The intensity of a force cannot be negative. So C is not possible. And the other two answers can be ruled out because of the order of magnitude. I think it's you can reach the same conclusion probably by ruling out the other, but it's not so easy. Anyway, this is what I would have done, okay? Just important, basic ideas from electromagnetism that you should remember. Then you move on to the next question. Is a uniform 2.6 meters long horizontal pole weighs 6 Newton. Newton is a unit of measure for forces. Kilograms for masses and Newton for forces. Remember, you should remember the units. So Coulomb, Newton, kilogram, there are meters, of course. You should remember forces. This is a question. Forces are measured in Newton. Okay, so this is a question about statics. Basically, you have this rod or pole. The weight is in the middle because it's uniform. So the weight 6 Newton, you can think of the weight as something applied to the middle point. The length, you know, and then at the right side, there is a force F is applied, and which forms an angle of 30 degrees with the horizontal direction. This is the situation. What is the intensity F of this force? If you want this to be in equilibrium, so this is fixed. So this pole can rotate about this point. You see, you should picture that this in principle could rotate. But then if there is no force F, this will fall down and go down vertically like this. But if you put a force F of an appropriate amount, of an appropriate intensity, which forms an angle of 30 degrees with the horizontal direction, then if you choose F in the right way, you get equilibrium. How do you, first of all, what do you do? Well, you look here and they say it's not nice to have this force in an oblique direction. It's better to have this force in a vertical part and to an horizontal part. So you go here, and then you see that this is the length of the pole. And then F forms a 30 degrees with the horizontal direction. So the horizontal component of this force is F times square root of 3 over 2. F times square root of 3 over 2. While the vertical part of that force is F over 2. Why? Because the cosinus of 30 degrees is F square root of 3 square root of 3 over 2. The sinus of 30 degrees, and this is a question from mechanics, from statics, because you want to find the condition of equilibrium. You have a rigid body, which is this pole. This pole has a given length, and the weight is 6 Newton. So you have remembered that Newton is the unit. You see, it's the second time we find this, okay? So Newton is the unit of measure for forces. And then you see that I have this pole with a given length L, and then there is a force at the end with an angle, forming an angle of 30 degrees with the horizontal direction. You want to find F, the intensity of F, in such a way that this is in equilibrium. On the left, there is it's fixed. The left extreme of the pole of the rigid rod is fixed, so it could, in principle, rotate about this. So how do you guarantee that this does not rotate? You need to impose that the torque of the forces about point O is 0. How do you compute? First of all, you split the force F, the horizontal, the force F, which I've drawn in red here, into a horizontal part, which is F times the square root of 3 over 2, because the cosinus of 30 is the square root of 3 over 2. And then the vertical part is F times the sinus of 30 degrees, which is 1 over 2. So you have F is split in two parts, F times the square root of 3 over 2, and F over 2, which is the vertical part. So how do you impose the condition that this does not rotate about O? The condition is that the total torque of the forces, of the two forces, basically, the three, if you wish, because you split F, the red F, into two parts, the total torque with respect to point O is 0. But how do you compute the torque of a force? You take, first of all, let's start with the weight. The weight is P. P, we call it P. P times the distance between the point of application, the straight line containing P and the point O. So L over 2. The distance is L over 2 times P. That's the total torque of P. And the total torque of F over 2 is L times F over 2. So they should balance. What about F square root of 3 over 2? It doesn't count, because this part of the force F is just trying to pull the rod in the right direction, on the right. But if the rod is fixed, so it can move. So there is no effect on the equilibrium by force. It doesn't make any difference, the horizontal part of the force, because it's just trying to pull the rope, the pole, to the right. What has an effect is F over 2, because F over 2 is trying to make the pole rotate upwards, and the weight P is trying to make the pole rotate downward. So they should balance. The torque, so it's not that P should be equal to F over 2. The torque of P, which is P times L over 2, should be equal, should balance the torque of F over 2. The torque of F over 2 is L times F over 2. So you simplify and you get that F should be equal to P. But P was 6 Newton and so F should be, P was 6 Newton, so F should be 6 Newton too. So the answer is 6. The answer is 6. Okay, let's go to the last one. This is the last one. And this was somewhat, you have a spring with a constant, an elastic spring, like you see in the drawing down here. You have an elastic spring, a spring, of course, all springs are elastic, with a constant K. K is 800 newtons per meter, divided by meter. Is compressed by 10 centimeters. What is, remember that 10 is centimeters, but you need to use meters because the constant K of the spring is expressed in terms of Newton and meters. So the length that you are using, the compression is 1/10 meters, because 10 centimeters is 1/10 meters. What is the modulus of the work performed to compute, to compress the spring? Here there are many approaches. The easiest one is to remember this, that the work of the force of a spring is the variation in the potential energy. The work done by the force is equal to the variation in the potential energy as you compress, as you change the length of the spring. But what is the potential energy of a spring? The potential energy of a spring is 1/2 K times the square of the compression. So if you compress by X, you introduce the spring will have a potential energy which is 1/2 K. K is the constant, the elastic constant. That's called the elastic constant of the spring. So 1/2 K X squared. But then, and then if you remember this, of course, it's easy because you know that X is 10 centimeters, which is 1/10 of a meter. So where there is X, you write 1/10 of a meter, 10 to the minus 1 to the square. K is 800 Newton divided by meters. And then we have 1/2 times 800 times this. 10 to the minus 1 to the square is 1/100. And so you get 40 Newton per meter. And then 8 divided by 2, no, 100. There is something wrong here. 4, yeah, I made a mistake, sorry. It's 4, and it did 4 Newton per meter, and it is 4 joule. And the correct answer is 4, not 40. Okay, 4. I made a mistake here. So it's delete the 0, you get 4, because you get 800 divided by 100 is 8. 8 by 2, 4. You get 4 Newton per meter equal to 4 joule, and that's it. And then that's it. And this is the end. So what can you say? Okay, so do you have any question?
Ti chiedono come possono prepararsi, se gli indichi
yes, sorry that I can't see your... well, that's a difficult thing. I mean, there are basic topics. There is a list of topics, very bit vague, a list of topics which is somewhat vague, published by the Ministero. There is document, 1 page. There is a topic, there is a list. You should check, you should look for them. And then there is this document which contains the main topics which could be in the test. It's a bit generic. It's very much generic. So you should check that. In order how to prepare, it's not fast to prepare. It's basic knowledge that on the assumption. Well, what I can say, you should not go into topics which are too difficult. For instance, electromagnetism, just basics. Mechanics, just basic idea. Vectors, equilibrium conditions. Kinematics, basically what is basic. A point moving on a straight line, a point moving on a circle. Velocity, the most basic, it's very basic. You should, there is never something advanced in mathematics, something really advanced. You should be careful that you should concentrate not on complicated equations. They are not going, because you're supposed to answer in a few minutes. So there's no way they will give you something which will take, like in the high school, maybe 1 page of computations, 2 pages. So everything is somewhat straightforward. If you have the basic principles clear in your mind. So go through your high school books, and then go through your high school books, and then check the basic ideas. Go through the basic ideas. So second degree equations, basic properties of logarithms, of sinus, cosinus, basic properties. So do some exercises at the basic level, but be sure, make sure that you have the basic ideas clear in your mind, because it's obvious they are not. It's not possible that in a test they will give you something very complicated, because otherwise no one will be able to do that in a few minutes. It's like every answer should be answered in a few minutes, so 3-4 minutes, something like that. So it's useless if you learn complicated things, very messy ideas, but just basic things. And of course, if you are talking about books, there are sorts of books in mathematics, but I don't know. But it's not possible to say study on this book or on that book.
Okay, Maria Cristina, maybe
it's not possible to do. Let's see this. Here I am. This is better.
Okay, now we see you better.
This is better. Yes. Okay.
I don't know if there are questions. Otherwise, we can show all together to say students goodbye.
Yes.
Maria Cristina, are you still here? Okay, it's a good idea to show.
Yes.
Andrea, if you want, Professor Campioli, who is the coordinator of the bachelor program. I don't know if he's here. Maybe he can show, say us goodbye. And also the technical team who has helped us a lot. We would like to say then thank you for your support. Maybe you can show as well. You can switch on your cameras. I cannot call you one by one, but maybe Alessandra Baresteri, Chiara Viganò, Marcella Pirovano, Maria Cristina Giurastante, and I think this is, and Luigi also, Esposito, the video maker in a way. Okay.
Okay.
It is a nice idea to have our faces all together in one picture. Any questions, maybe? We did our best to answer questions one by one when they arrived during the afternoon. Maybe if any new question will arise, please write us and we will try to answer you. Questions? Okay, I don't know who is allowed to close the meeting. By the moment, from the side of the teachers, I say thanks for participating. We hope that everything was clear and most of all helpful. And we are looking forward to have you as participants in the test. Have a nice summer.
Okay. Yes.
Okay, goodbye.
Okay.
Thank you.
Goodbye.
Bye.
Goodbye.
Bye.
Goodbye.
Bye.
Goodbye. 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 Goodbye.